In this lesson, we're going to look at how to add and subtract fractions that have like denominators. Now remember, denominators only indicate the size of the pieces, not the amount of pieces. The top number tells you how many pieces, and the bottom number tells you how many it takes to make a whole. So if we look at this example, 3/7 plus 2/7. I have here 3 pieces. It takes 7 to make a whole. I have here 2 pieces. It makes 7 to make a whole. So these pieces are the same size, and I could easily say that I have 5 pieces total, but it still takes 7 to make a whole. So see, when you add fractions, when you add pieces together, that does not change the amount of pieces it takes to make a whole. So the denominator stays the same. And here's another very similar example. 3/11 plus 4/11. The pieces in each fraction are the same size. So I have 7 pieces total, but it takes 11 to make a whole. And again, here's 11/12 minus 5/12. The pieces in each one are the same size. 11 minus 5 is 6. So I have 6 pieces. It still takes 12 to make a whole. Now notice that 6 and 12 can both be divided by the same number. That means they have common factors. If I write 6 as 6 times 1 and write 12 as 6 times 2, we can cancel these 6's. We always want to make sure that we leave our answers in simplest form. So let's cancel those 6's, and that will leave us 1/2 as our final simplified answer. Now let's look at a couple of examples that start with mixed numbers. So to be on the safe side, you should convert all of your mixed numbers to improper fractions first. That just makes sure that you avoid any problems or any errors that are due to borrowing and carrying, because the rules for adding and subtracting mixed numbers are a little different than regular numbers, but you can avoid that completely if you just change everything to improper fractions first. So let's look at 3 3/8 minus 1 1/8. So if we change this to 27/8 minus 9/8, because 8 times 1 is 8, and then you add the 1. Now 27 minus 9 is 18. So we end up with 18/8. And we're going to change this. We're going to reduce this actually first. So 18 is 9 times 2, and 8 is 4 times 2. And these 2's will cancel out, and that will leave us with 9 times 4. And now, because our problem was a mixed number problem, we're going to change this back into mixed number form. 4 will go into 9 twice, with 1 piece left over, so that is 1/4. Now, I would call your attention to the fact that you could do whole minus whole here and get 2, and you could do 3/8 minus 1/8 and get 2/8, which simplifies to 1/4. And sometimes that works. And if the first fraction is not bigger than the second fraction, that doesn't work. So the safe way to never have to worry about it is to just change everything to improper fractions first. No more than we're going to be doing this. It's just the easiest thing to learn. Okay, here's an example where you can't do that. See, 1/4 minus 3/4 doesn't make sense, or it gets you into the realm of negative numbers, and we don't want to do that. So instead of trying to subtract whole number minus whole number and fraction minus fraction here, the easiest thing is to change this to 21/4 and convert 2 3/4 into 11/4. Now 21 minus 11 is 10, so we get 10/4. Let's simplify that fraction. 10 is 5 times 2, and 4 is 2 times 2, so these 2's will cancel out, and we'll have 5/2 left. And convert 5/2 back to a mixed number. 2 goes into 5 twice, with 1 piece left over, or 1/2.